Today we're going to look at variation, which is like direct variation and inverse variation. You would have seen this before, ideally. Sometimes it's the thing that gets cut when we run short of time. So we'll see if this is new or something that you've seen before. We have a few different types of variation, and a variation is just comparing two values and how they vary, obviously. As for direct variation, you'll find that as one value increases, the other increases proportionally. And it's always going to look like a linear situation. And it'll have a constant slope. So maybe that slope here is 2 or 3 or whatever it might be. That stays consistent, which is making that be a linear situation. Inverse variation, as one value is increasing, the other one is decreasing. Example of that could be like our rational graphs. Like as I go further to the right, my y value is actually coming downward. Let's start with this direct variation idea. Now, as I mentioned, it would be like a linear relationship, but it's even simpler than that. We're going to have the y-intercept always be 0. So it just looks like the y equals mx. And we use a k for that constant slope. The k is going to be a constant in all of these different variation equations. This is a pretty simple little equation. It's a linear model, and here's how it's read. It says y varies directly, or sometimes you'll see the word that it varies proportionally to x. If you see this word directly or proportional, or sometimes it just says y varies as x, because the default is for it to be directly varied. Now, k is the constant of variation or constant of proportionality. Now, we can tweak this model to be something other than linear as we start getting a little bit fancier. So that'll come up as we do some further examples. Let's try one here. I'm just going to keep it with x's and y's and keep it very basic here to start with. It starts off and it says that y varies directly as the square root of x. Now that's fancier, okay? So this is no longer going to be a linear situation because I'm dealing with a square root now. And y is 14 when x is 94. Find x when y is 34. Now, I kind of cut all the riffraff out of this, and it is just boom, boom, boom. Here's some key information. But pretty quickly, it's not going to look quite that way. I'm going to have a lot more stuff in there. So I've got us kind of this 3-step system that should work every time for you. And something happened funny with mine, and sometimes it's weird because it got cut off for me right here, and it just says set up the model. But I found that sometimes it's not cut off for you, which is the weirdest thing ever. But there's more to this. It should be in your notes. It says set up the model and solve for k. You have to recognize what type of variation you're using and use the proper equation. Y equals kx is the one we use for direct variation, and it did say it varies directly. Now, our goal is to solve for k, and I'm going to use this information to figure that out. Now, it's really not y equals kx. I just know that it's direct variation. I have to follow what it says. It says y varies directly as the square root of x. I need to change this x to a square root of x. Now, that's the real model. And then they tell us some values. They tell us that y is 14 when x is 94. I'm just going to plug those in, and I'm going to then solve for k. I'll just take 14 and divide it by the square root of 94. I get k to equal 1.44. That's the first step. You got to figure out what the k is. Now, the second step, oftentimes, these are the 3 things that are asked for. They'll ask you, find the constant of variation. That's a fancy phrase for k. And then they want you to write your new model. Well, your new model no longer has a k. It has the value of k. It's going to look like this. Y equals, and instead of k, I put in my 1.44 square root of x. This is the new model when they're asking for that. That's always step 2. And then sometimes there's just one question, sometimes there's many, but you're going to use your model then to solve whatever they want you to solve for. In this case, they just want us to find x if y is 34. Y is 34. I'm going to solve this for the x. Looks like I need to divide by the 1.44. I'm going to try to be careful to use exact values. So I'm going to go up and grab that 1.44 number on my calculator. I end up with 23.55 is equal to the square root of x. And then I'm going to square both sides to get rid of the radical. And I'm just going to hit a quick answer squared. And x is going to be 554.41. All right, so I'm going to try to, well, I am going to use this three-step model every time. Go through those 3 steps. Those are going to be the 3 things. Every problem on your homework's worth 3 points. I've even given you a sheet of paper to do it all in these 3 steps. Let's try another one. This time it says the distance a ball rolls down a ramp is directly proportional. All right, I got that direct variation going again, to the square of the time that it rolls. All right, step 1 is to write our model. It's direct variation. So I know that I'm going to have that k times my x, but I have different variables here. It says that the distance a ball rolls down a ramp is directly proportional. So that's going to be k times something to the square of the time it rolls. That's a fancy way of saying the time squared, not square root, the square of the time. Now, then they follow up with a little piece of data here. During the first second, the ball rolls 8 feet. That means that when my distance is 8, my time was 1. And it looks like pretty easily I can see here that k is going to be equal to 8. So I found the constant of proportionality. Step 2 is to write the model that we are going to use. That's now going to be d equals, instead of the k, it's an 8 t squared. This is the new model. Step 2 is always just you putting your k value in and writing a nice model. Step 3 is going to be to answer this question. Use your model to find the distance the ball travels in the first 3 seconds. All right, I'm looking for the distance when the time was 3 seconds. I've got 72. Now, this was more than just X's and Y's. This means something. We need to be sure that we put a label on this. Distance was measured in feet. And we've answered the question. Let's take a look at inverse variation. Inverse variation has your constant being divided by that item that you're varying it, but the x or the x squared or the square root of x or whatever it is. It will always have that variable in your denominator. And so this says y varies inversely or is inversely proportional. So they might say this proportional word again, but the inversely, that's what you're looking for. If it has that word, you know you're using this formula. K is the constant of variation or the constant of proportionality. Now I'm going to get fancy on us here. I'm going to actually combine some direct and inverse variation all going on in the same problem. There's a lot of physics formulas that we use that have this variation in them. If you're in physics, maybe you're familiar with that. Some of these, I'm going to guess most of you have not taken physics. All right, here we go. The volume of an enclosed gas varies inversely as the pressure and directly as the temperature. All right, let's write that model. The volume, now you always have to have the K value there. So I'm going to put my K, and it varies inversely as the pressure. So that's going to look like this. And directly as the temperature. That's not a new problem or a new formula. You incorporate it as part of this. Directly means you multiply by the K. So directly as the temperature. And so that's what my formula will look like. Then they're going to come back and give me some data so I can solve for K in this first step. The pressure is 0.75. When the temperature is 294 and the volume is 8,000. We're going to solve for K. First thing I want to do is go ahead and take the 0.75 to the other side by multiplying. And I end up with 6,000 over here. And then I'm going to come back and divide by the 294 number. And I get 20.41. That's my K value. That's step one. Find the constant of proportionality. Step two, just rewrite the model with your K value in there. Done. Step three is to use the model to answer some question or questions. This one says, write the variation equation. We did that. And find the pressure when the temperature is 300 Kelvin and the volume is 7,000 cubic centimeters. We just fill in everything we know. We know the volume is 7,000. We know K is now 20.41. We know the temperature is 300. And I'm solving for the pressure. To solve this, I'd go ahead and get rid of the denominator same way. It's just that I'm going to be taking it times P. I have 7,000 P equals, if I take that K value times 300, I get 6,122.45. And let's divide that by 7,000. And we are getting the pressure of 0.87. Let's take a peek back. Pressure of the gas is measured by kilograms per square centimeter. Be sure to go ahead and label your answer on that. All right, I've got one more. All right, this video is kind of glitchy. All my stuff didn't come through like I would have liked. I was totally missing this slide. Third type of variation is joint variation. And that's when you have more than one or two things going on. Really, you have three things going on. And it can be fancier than that even, but that's what we'll stick with. I still have my constant of proportionality here. And I have these two things being multiplied. That's always going to be the case, that these are multiplied. And then I have my other value here. And so this is read Z varies jointly as X and Y. There's no division that goes on with this unless by chance X or Y happen to be a fraction. But ultimately, it just looks like this. This is when you have more than two things that are affecting each other. Now, ultimately, the problem we just did would have been this type, except that joint variation always has multiplication here. And that last one, we had some inverse variation going on with it. So then we had that X or that Y in the denominator. This one here is a classic joint variation type of problem. It's the simple interest for a bank account, which we have already done back in chapter 1. We did interest. And if you'll recall that the interest that you earn on an account is equal to PRT, the principal, which is the amount of money you put in the account, times the rate, that's your interest rate, times the time, how long you left it in there. Let's see how they're wording it. It says the simple interest for a bank account is jointly proportional to the time in years and the principal. What they're making, that if they're saying it varies by the principal and the time, they're making the rate be a constant then. It must have a constant percentage rate. After 1/4 of a year, the interest on a principal of $5,000 is $43.75. Write an equation and find the interest after 3/4. All right, let's start off by maybe rearranging this. I'm going to do I equals, I don't know what the rate is. That's going to be my constant that I need to go search for. But the principal and the time were given to me. Let's fill those in. And the interest was given me. I earned $43.75 when I had put in $5,000 and I put it in after 1/4 of a year. Now, time in this formula is always measured in years. So I didn't even leave it in for a full year. I have to put a 1/4 here for 1/4 of a year. Or you could put a 0.25 there. That would work as well. All right, so first thing I guess I'm going to do is go ahead and take the 5,000 times the 1/4, and that comes out nice for me. And then I'll divide by the 1250. And I have a 0.035, which is not a terrible answer, to be honest. That is an interest rate. Okay, I'm going to keep that. I'm going to box that in because that's what I'm going to use for R. But just so that you have an awareness that what you would be doing here is moving your decimal over 2 places. That is a 3.5% interest rate. But we don't want to write it as a 3.5. We want to use the decimal value as we work through this. Okay, step 2, always write your cleaned up model of what you're actually going to be doing. And then step 3 is going to be to use that model. It says write an equation to find the interest after 3/4. All right, so we're going to assume we still got the $5,000 there. I'm going to do 0.05 or 035 times the $5,000. And then after 3/4, then I'm going to put in a 3/4 or a 0.75, however you want to do that. And we're just going to multiply that all together. And we get $131.25. Okay, now this one was, oh, and don't forget your dollar sign. Now, in all honesty, I was just kind of practicing this concept of joint variation and using a formula you're familiar with. This, I don't know that I gave you the best options here because ultimately, if I left it in for 1/4 right here, then 3/4 is just going to be 3 times that. If you take this times 3, you're going to have that. I guess we could just use that as a check, but ultimately they're not all going to be like that. So be familiar with that formula. Okay, that's all I've got for you. Have a great day.